review of the Edgenuity lesson, evaluating logarithmic expressions. So to start off, on your calculator, if you have a graphing calculator at home, you'll notice that there is a log button on there. But this log button is the common log that they talk about, the one that's base 10. So you can't use your calculator to do log base 2 of 32 because this is log base 10, and I can't put in a value in there. With that being said, there are some on the quiz where they say use your calculator. Let me look at one here. It says, no, I can't find one. Oh, what is the value of log 43 is one of the questions. So if it's just log 43, you can use this button on your calculator and go 43, enter. And then that value would be about 1.63. So to start off, to help us get better at evaluating logarithmic expressions, we need to practice switching them from logarithmic form to exponential form. And the phrase that I always use to rewrite it in exponential form is base, answer, exponent. Because that's the order that it's laid out if the equal sign is on the right. So it goes base, answer, exponent. Base, answer, exponent. So what I mean by that is we're going to have base 2. The answer is 32, and the exponent is 5. So the exponent on our base. So again, and 2 to the 5th power is 32. So on this one here, base, answer, exponent, which makes sense. 5 to the power of 0 is 1. Base, answer, exponent. Base, answer, exponent. And all of those are correct. 10 squared is 100. 1/2 to the power of -1. Remember, you have to flip it. You get 2. So when we are evaluating these logarithmic expressions, we're going to use exponential form to help us out. Now, some helpful hints here to figure out what your answer is. If the base, meaning in exponential form after you switch it, if the base goes from a whole number to a fraction, or from a fraction to a whole number, the exponent has to have been negative. If the base stays a whole number but decreases, then the exponent is a fraction. So you're taking some type of root. So let's look at the first one here. So we don't know, I'm just going to put that this equals x. In the video they use a question mark, but I'm going to say this equals x. So if I wrote this out in exponential form, I would go base, answer, exponent. So we have to decide what exponent would we put on a 3 to make it be 81. So what you can do is, if you ever don't know, just guess and check. Nope, nope, nope. Oh, there we go. 3 to the 4th power is 81. So that means this log base 3 of 81 equals 4. So that's our answer there, 4. Now let's look at this one. Base, answer, exponent. Okay, so this is the one that I was talking about here. We start off with a fraction, and we end up with a whole number. That means whatever this exponent is, it has to be negative. So we have to decide, basically once you decide it's negative, that takes care of the part about it being a fraction. Then you can just look at the 2 and think, what exponent would I put on a 2 to make it be an 8? And that would be 3. 2 cubed is 8. So the exponent here is -3. So log base 1/2 of 8 equals -3. You can always check your answer as well. So if I go 1/2 to the power of -3, I get 8, and I do. Again, on this one, you can guess and check. If you know the exponent has to be negative, you would just start with -1, -2, and -3 until you get to positive 8 there. Okay, so let's look at the next one. Base, answer, exponent. Okay, so again, we went from a whole number to a fraction, So I know it has to be negative. Then once you take care of that bit of it turning to a fraction, you can just look at what exponent would I put on a 5 to make it be a 25. It would be 2. So log base 5 of 1/25 is negative 2. Next one. Base, answer, exponent. Okay, so on this one, it didn't change into a fraction, so it's not negative, but it did go down. It went from 9 down to 3. So what I wrote right here, if the base stays a whole number but decreases, the exponent has to be a fraction. And as a reminder, I'll write some things right here. If it's the square root of a number, that exponent is 1/2. If it's the cube root of a number, that exponent is 1/3. And if it's the 4th root of a number, I don't think they'll go much higher than that, the exponent is 1/4. These are all equivalent things. So what root would we take of 9 to get 3? The square root of 9 is 3. So the square root goes with a fraction exponent of 1/2. So log base 9 of 3 is 1/2. Okay, so now let's look at some where we're solving. So it says solve for x. So right now we're in logarithmic form. It says log base 3 of negative 2x minus 3 equals 2. So if we switch it to exponential form, it's going to help us out. So base, answer, exponent. So if we evaluate our exponent over here, 3 squared is 9. Now we just have a regular equation. Add 3, divide by negative 2. Negative 6 there. Okay, so next. On this one it says log 2t plus 4 equals log 14 minus 3t. So since they're logs with the same base, the common log, base 10, for these to be equivalent, this part on the inside has to be the same. They have to equal each other for it to be a true statement. So we can just pull that part out and say 2t plus 4 has to equal 14 minus 3t. And t would be 2. And you can always plug it back in to see if you are correct. So 2 times 2 is 4, plus another 4 is 8. 14 minus 6, also 8. So we would have log 8 equals log 8.